Today's job is to convert these codes used in the terminals of this phylogeny into a format which can be integrated. Now this is one of the most widely cited phylogenies of beetles, and almost 10 years old and still the most comprehensive beetle phylogeny made. And I have the machine readable version from Ladder's Lab, and you can see the terminal IDs here are not a typical format. Now this is interesting. These were developed some time ago. These are strings which are built up from the lineage for each terminal, and I can show you why that's useful when you're visually checking a phylogeny. You can see, you can type into the tree view something like, as long as you know roughly what these are. Maybe these are Curculinoideae or something, maybe the weevil family. Just type in a string and it will highlight all members of the weevil family, so you can check very easily monophyly, and you can check whole groups of things. So that's why these were developed. But for synthesis purposes, they cannot be integrated with the standard taxonomic system without some key. Now, unfortunately, the key, i.e., what specifically does this correspond to, what exactly does it correspond to, was not available. Now, initially, I did try. I developed the original script which did this. So I used a few old key files that I happen to have, and none of those really matched well. The problem is, every time you run this a process to develop this string, each time it's different. Now it can be just as someone uploads to NCBI a sequence from, say, a new genus which hasn't been done before, and then that will have ripple effects and it will change the codes for a bunch of relatives, so the strings are no longer exactly matching. So if they'll exactly match, then you can't match them. So the old key files I had didn't really match very well. I tried creating new ones somewhere here. Yep, this one. So this is the script which does this. Had a few old versions of this and a few old versions of the NCBI taxonomic database. So I tried recreating this, and it was a bit. Eventually, I got somewhere a bit close, and maybe 90% of the codes I could match. But yesterday, I looked at this again, and I think I can do this more completely now. How? Because in a supplement to this, I noticed this. Now these are all the codes, and it has the NCBI accessions for the sequences which are used for that terminal. So I figured out, actually, I could just query NCBI for all these accessions and get the details that way, because the details of the species and the lineage will be in the NCBI entry. And I've done something similar recently, so that's why I figured out I could do this. So new script parse the botsac table. So I copied all those from the supplement into a text file and parse this. Quick look at this. So the format of the table is the code, space, and the columns of which have the accessions in them. So I'll just pull out the accessions and just take any. A lot of them missing, so just take any accession which happens to be available for that code, and then just use the eSearch tool, one of the eUtilities, and then using the NCBI accession, then write each of those to a file. I've called this isn't poorly named. This is actually the taxon code. So each write to individual taxon code, and you can see it all here. So here's the taxon codes which have been used, and in here will be the NCBI entry. So it's this GenBank full format, and you can see the information here. Organism has the species label. So then we just need to parse this. So another thing, job equals 2, so I don't need to repeat all the code. Then if job equals 2, we don't query eSearch, we just parse each of those files I just showed you, and then here's the code for pulling out the organism name, and also the NCBI taxon ID, which is given to each species ID and higher taxon name, just in case some of them have weird IDs, and then print these to file, and we now have the inferred species IDs here. So here's the original codes. I didn't know couldn't be matched. Most of them could be matched, but we want really ideal. Just want to match all of them. We want to maximize the information content. So we've pulled out from that table one of the NCBI accessions used, and we have the parsed out from the GenBank flat file entry. We parsed out the species ID, and here's the NCBI taxon number for that. Probably won't be needed, but we just need this, and then job done. We now know what these are. So with this, I can now transfer these regular binomials and regular formats IDs into this tree file, and this can be integrated into a synthesis tree.